Hello and welcome to our Precision Forestry webinar series, which we started on 28th of January with the introduction to smart forestry. And today we are focusing on the digital inventory technologies around the same concept. My name is Jani Kaskinen. I'm Senior Principal in AFRY Management Consulting Bioindustry sector, and I'm working on digitalization initiatives. My background is on the software and ICT industries, and the past few years I've been working with the forestry technologies. Nice to see so many of you joining. Hope you enjoyed the webinar. With me I have Jussi Rasimäki and Ismo Hippi here as an experts. Please, guys.
Hello and welcome on my part as well. As Jani said, my name is Jussi. I'm CEO and one of the founders of Simosol, and my background is quite firmly in forestry, but more specifically in bringing forestry and ICT together.
Yes, hello everybody. As Jani said, I'm Ismo Hippi and I'm coming from Mosaic Mill Ltd from Helsinki region, Finland, and we are startup or young company developing forest inventory methods based on drone data. And I'm a forester as a background. Thanks.
All right, so let's get into the topic. So we're going to talk about the digital forest inventory and the fundamentals of forest inventory, and then kind of, let's say, latest technologies, including imagery and lidar technologies, and then kind of conclusions around that. Keeping it in an overall topic, which is kind of the precision forestry and smart forestry offering that we have, starting from digital inventory, going to the site-specific management, simulation and optimization of that digital inventory, IoT-based tracking systems, logistic systems, and so on. But everything kind of starts with the accurate digital inventory. So I consider this probably the most important aspect on the technology side nowadays, and knowing also that there is a lot of technologies to cover the supply chain overall, but they all kind of suffer from let's say inaccurate inventory data. So measuring the forest, Jussi, I let you explain how it's done so far.
Yeah, this, as you can see, this image is going back a while, and well, as we hail from Finland, it is actually this kind of national level forest inventory, forest measurement. It actually goes back more than 100 years already, done in a systematic way, and it's been done the same way more or less the whole time, which is the inability for us to actually kind of see the individual trees from the forest. So what the traditional or until 2020s approach has been is measuring a sample of the trees to be representative of the forest. So individual trees are measured typically, but only a small sample of the total tree population. And then this is the kind of handicap in a way of having the full picture of the forest as we have here on the right for today, which is an actual 3D model of every single tree in the forest versus having a sample of the trees measured in detail. So this is kind of the paradigm shift that has happened in the recent years. The story is of course more complicated than this. It's not immediately jumping from measuring the one tree with the device like we see on the left to having this 3D model. There are different stages, different approaches in between, of course, but this is kind of showing the extremes of how forest can be measured.
Right, and I guess the technologies around measuring or modeling the forest with the LiDAR and imagery has been there, but it's been somewhat inefficient and expensive to do. Let's say up until now, and it really depends what the business case around it is, how important it is to have accurate data.
Yeah, there is always this very traditional trade-off in forest inventory. What is your measurement budget and how accurate results do you want to get? I mean, there has always been a trade-off, and still today there is a trade-off. But I would say that we have brought the price curve down, so it costs now less to get very accurate results than what it did earlier. That's probably the kind of economic-wise the most significant change.
Right, and I think to be fair, the business case of how you do the inventory is somewhat difficult if it's only, okay, now you get more accurate picture, so what? But the business case comes from kind of all the processes after that.
Exactly.
That will benefit from it. Yeah.
Exactly. What we saw on the previous slide, the other squares were kind of multipliers for the benefit that the more detailed inventory brings. So it's on its own, it's okay, it's valuable to know what you have in detail, but where the real benefits come is what happens after the measurement and the planning for the management, etc. So they are really the kind of benefit multipliers in this picture.
Absolutely, yeah. So let's get into the actual process of how the imaging is done within the forest and also the different layers of that. So on the right-hand side, we have two pictures. I guess the greener one is combined LiDAR data with the RGB imaging. And what about the picture on the top? Ismo, are you?
Yes, yes.
So can you tell me a little bit about those pictures on the right-hand side here?
Yes. So this upper picture, this is taken by camera system, while the below picture is by LiDAR. And this is when we are taking LiDAR data, so it's always black and white, but we are using RGB imagery to put those colors into the picture, or actually to the point cloud. So final result looks more or less the same, whether it's RGB camera system or LiDAR system.
Right. And what about those vehicles to take those sensors out, the drones? This specific one is made for forestry use, is that right?
Yes, so it's important to have right kind of sensor setup in the drone. So for example, if we are looking after species, we need to have more bands, not only RGB, and then we need to have accurate GPS equipment on board. We are using typically PPK or RTK level GPS equipment. And of course, there is a very important part is this gimbal system, how cameras are put together, what is the direction they are looking, and so on. How well the cameras are synchronized. So it's a complicated, but not too complicated. It's possible to make this kind of setup.
Okay, and for the differences between LiDAR and RGB, you can today you extract the point cloud from either or, correct? So the LiDAR point cloud is, well, it doesn't have any colors, right? So it's just for the accurate measurement. And what about the differences between those point clouds as far as the volume measurement?
So the biggest difference, of course, between LiDAR and camera data is that the LiDAR is able to see the ground. So this is the big difference. And this is also the key to decide what kind of sensor we should use.
Right. But I guess you will need a RGB sensor at least to get the species recognition and that kind of information.
as you mentioned, so it's only black and white without camera, so it's much easier and better and more visually usable after applying also RGB camera data.
Right. So can you talk a little bit about the differences then on plantation environment? Easier, harder, or the same as far as the measurement?
I would say that you can use both systems, but when we are using LiDAR, you have less points. So with LiDAR, typically we have 50 or 100 points maximum per square meter. While if we are using camera system, you can easily reach 500, even 1000 points per square meter. So it's let's say that it is more detailed if we are using a camera-based system. But then if we don't have this terrain information, then it might be that LiDAR is a good option.
Right. How do you see, Jussi, on your point of view, differences between the Nordic and plantation forest as far as the measurement? My assumption would be that there's better weather for drones in a plantation environment typically, but is there more other disturbances? I guess that also the trees and the plantation is more equal, so it's easier to calculate the volumes.
Yeah, in natural or semi-natural forest, the one problem to solve in the inventory is what species of trees do we have in the area, whereas in plantations this is typically given. We know what has been planted in that area, but still it's the same problem that we solve with this inventory in the plantations, just a different aspect of it. So in plantations, what the spectral information in the camera images is used for is for estimating the health of the tree or possible fungal spread outs or pest outbreaks in the plantation. So generally the health status of the canopy, not so much the species recognition, but still the same data is used for it. And as far as the kind of dimensions of the trees go, yeah, it's pretty much the same issue to solve in both contexts. But of course, in plantations, as you said, the trees are of more uniform size, so there is less problems with this kind of detecting the vertical structure of the forest. It essentially has a single canopy layer, and in that sense, it's easier to measure.
Right. And for the go into the actual system, but one more question, because you brought up the diseases and probably pest control kind of issues. So what kind of a sensor do we need to detect those kind of abnormalities that can be quite minor? Ismo.
Yes, so in plantations, of course, RGB is enough to detect dead trees. So that is quite easy. But then if we need to detect or make more detailed analysis, we call it green attack, the phase when we don't see it by our eyes what's happening, but there is still already something happening. Then we need to have more detailed information from camera. And then we start to use multispectral data and hyperspectral data. Well, maybe this is giving the answer. So not only one solution, but we have to check what is the situation, what is the geographical area, and then we make the decision of the sensor.
Right. Okay. Yeah. So let's get to the actual creating the digital inventory and start with the canopy height model. Jussi, you can kind of start explaining through how do we build this up? Right.
We've mentioned the point cloud already a couple of times, just to kind of clarify that what it actually means. It means that we have a data set where we have points, and for each point we have X, Y, and Z coordinates. So we know where the point lies in the 3D space. And here there are essentially kind of two surfaces created from these point clouds. One is the digital terrain model, which says that at this X and Y location, the height of the altitude of the terrain is this. So it describes the kind of not changing feature of that particular piece of land. What is the altitude above sea level for that point? And then this middle image here, the grayscale image, that's one of the kind of essential outputs of the imaging flights, and this is the point cloud converted into a surface model that tells where the canopy surface lies in this 3D space. So we have an X, Y, Z coordinate for the soil or terrain, and then we have X, Y, Z coordinate for the tree canopy. So this part of what ultimately happens in this image to produce the canopy height model, which is there on the right, is elementary mathematics. It's just subtracting from the canopy surface model the digital terrain model, and that will tell us the height of the canopy at each location. It's of course not elementary mathematics to actually generate the digital terrain model and the canopy surface model, but once we have those, then we just subtract them from each other, and we have a kind of surface that tells us that the canopy has this height at this location.
Right. And do you create the digital terrain model? I know some of the companies have that in place, but there's been some issues that it's kind of hovering a little bit, or it doesn't represent the actual height. How do you correct that piece? Ismo can answer.
Yes, so yeah, this digital terrain model is really important, so we need to have it. So of course the best situation is that if that exists like in most of the Europe and northern countries, let's say so, then if we don't have it, we can use existing model. Most of the plantation companies, for example, they have created digital terrain models already in previous act. So it's rather easy to adjust those models, calibrate those according to the more accurate GPS used in new flights. So this is possible.
Right.
And it's a good method. Then one more solution, of course, is to put quite simple LiDAR into the platform, into UAV, and fly together with camera. Not trying to get perfect point cloud, but to get ground well enough.
Right. Okay. Yep. And I guess especially on RGB imaging, you need to have a terrain that you have at least some visibility to the ground.
Yes, exactly. So those points can be used for calibrating the existing model.
All right. So you created the canopy height model by putting those two layers together. Please continue.
The next step is then, once we have the canopy surface model, is we're not really that interested in the canopy surface, but we are really interested in the individual trees. So the next step is then to isolate from this canopy surface model the single tree canopies, and then once that is done, then we can start generating attributes for these trees. So this is again the digital elevation model was crucial data source for having the canopy height model, and then next crucial step is being able to isolate from the canopy height model the individual tree crowns, because then that is the basis for both species detection if that is needed, but also this kind of quantifying the attributes of the trees, other attributes than species.
Right. In these pictures, you have it's quite easy to see where the trees are. Is there already an indication of the size or the volume of the tree?
Yeah, the first attribute that we get from this, and I would say by far the most accurate tree level attribute coming out of this kind of inventory is the tree height, because that's directly what is being measured here. So these circles, they are kind of an indication of the tree height, and it's kind of easy to do a visual verification of the results, because we can see that the smaller crowns of trees, they have a smaller height as well, and the bigger the crown is, the higher the tree is.
Right. One again side question about that drone is, for you probably know, that specific one that we saw, that I think the flying time was about 1 hour, and it covers what, 30 to 40 hectares. What are the most hardcore drones? What is the longest flight or area covered?
Yes, so that model was about 60 minutes, and that is quite good for quadcopter level of drones. So then we have, let's say, modern VTOL drones, which mean that what means that it goes like a helicopter up, and then it turns into fixed wing mode, and those can fly up to 2 hours. And then third alternative is hybrid drone, which is combination of, well, like in cars, so it's combination of engine and electricity, and those fly about 2 hours as well.
Oh, okay. So you can cover quite a big area with one flight today.
Yes, so let's say on those basic drones, it's about 40 to 50 hectares in one flight. So it means that one day you can cover up around 200 hectares maybe. If you are able to close the airspace, for example, in plantation conditions, then you can go higher and you can cover more, maybe double. So, and if you have hybrid drone flying long time, then it can be 3 times more, so easily 500 hectares a day.
Right, okay. So yeah, Jussi, sorry about that. I thought that was interesting. Important thing to understand as well, that what are the flight times and then what kind of fleet would you need depending on the area, of course. So yeah, we got the trees recognized here, and then we go to the next stage.
Yeah, this is where we then shift to modeling. So on the previous slide, we had the, let's say we had the species recognized, and then we had the height measured from the point cloud. And besides that, also the tree canopy or tree crown attribute, how wide the tree crown is. Those are things that are measured, and then rest is modeled. So of interest for basically for traditional reasons, because if we look back to the beginning of this slide set, we had this in a old slide where a man was measuring the diameter of the tree. That's the attribute that has been typically measured because the inventory has been on the ground.
He's still there. Yeah.
Yes, yes. So that's the kind of traditional attribute that forest inventory very much relies on, having this diameter information. But when we are making the inventory from above, the natural dimension of trees to measure is, like, as we have discussed, is the height. So now in this type of inventory, we have measured the height, and now we are predicting the diameter. And then this is done on this kind of with the help of allometric models, that if we know the species, we need, you know, the height, we know the crown, tree canopy or crown attributes, then the diameter is like this. So ultimately we have this kind of complete enumeration of trees in the area, each tree having the species and size attributes. And then we can of course also model other attributes. Well, always ultimately what we are modeling are the volumes, the total volume and different timber assortments volumes from the stem of the tree. But that's the kind of, that's really the crucial point in here that instead of a sample, we have an enumeration. We have measurements of all the trees in the forest, which you can, in a way, see there on the right, a kind of good illustration. There are some white dots there which illustrate dead trees. And if we are thinking of having a sample of this forest area, it's rather unlikely that we would have these dead trees in our sample, but in the complete enumeration of the trees, we do have them. Kind of
or vice versa, I guess. If somebody goes and takes the measurements in the area where there's a lot of dead trees and can apply that over, then.
Yeah, that's the traditional kind of sample stratification problem in sample-based inventories. That is your stratification good or not? Because you are always going to do the generalization based on your samples and the stratification. So that is kind of one aspect that goes away completely in this kind of inventory.
Right. I guess there's quite a calculator behind, and not going into details of that, but there's a species recognition. Can you open up a little bit how that's done in the background? Is that based on the kind of image recognition, or?
That would be for Ismo.
Ismo, sorry.
Yeah. Clarify.
Yes, of course. We have artificial intelligence algorithms carrying out that part. So, and those algorithms, they have to be trained. So it means that we have to show for the algorithm certain amount of trees, and then it is learning and is able to do the same kind of classification in new areas. This is if we simplify the algorithm. Of course, it's much more complicated in reality.
Yeah, and simplified version is good because I can digest that. So, but then each tree characteristics is different by kind of species. So then I guess there's a model to calculate the volume per species behind the scenes.
Yeah, that's right. We for different areas with, let's say, tree species that haven't been inventoried in this way, then one part of the inventory process is we are not getting completely rid of samples. We need the samples for the models, creating the models. So we need as I mentioned, we need the diameter model, which based on tree height and then the canopy attributes, which are strictly speaking not that common over the globe, because this is not typically done previously with forest inventories. So samples for those, and then luckily together with those samples we can also have this kind of volume model, and we tape a curve the sample trees so that we can model the tree stem, because that is really what we are after in these inventories, knowing the characteristics of each stem in the forest, and what is the total volume, what are the possible different assortments that we can get from the stems. So that's definitely a kind of crucial part again of this kind of inventory approach, is having these prediction models that we need for the inventory.
All right, so now starts the grouping or building up the management units, correct?
That's right, because I don't think we are, as you can see from this presentation, we are really there for measuring the trees tree by tree, but I don't think we are very close to managing the trees tree by tree. So once we have this complete inventory of our trees, we somehow need to group them into areal units that we can think of doing forest management on. And this example image, like the previous ones, these are from boreal forest. So we see more variation in the forest landscape than we would see in a typical plantation, but that doesn't mean that there isn't variation in the plantations as well. So this same step applies both to natural, semi-natural, and planted forests, in the sense that you would want to target your management actions as precisely as possible. And this is where we kind of circle back to the original early slides of this webinar, where we had the site-specific management mentioned, and I talked about the multipliers for the benefits for this inventory. And this is now we are on that topic. What would be the management units based on the inventory trees that we want to create? And this is a topic of its own for a webinar, how to delineate or define the management units. But this approach kind of gives a very good starting point, because you have a big group of trees, and then your problem is divide the landscape into management units that have as similar trees as possible, and those would be your management units. But then again, of course, there are practical considerations in deriving the management units. For example, in this image, you can see that not every single group of different trees are grouped as a management unit of their own. There are considerations like the minimum viable area for a management unit. So they need to be, for practical reasons, above a certain area, for example. And these can be taken into consideration, of course, in this process.
Right. So I guess the precision forestry is not yet tree level treatment, or it doesn't make sense. How do you see differences between now created management units versus the old way of doing the compartments? I guess they are more granular.
They can be, but there we are really kind of on the constraints put on the management unit generation from the kind of practical context. That, as I said, that doesn't necessarily make sense to create management units of 0.05 hectares or 0.1 hectares, because it's not feasible for the management actions. It really depends on the intensity of the forest management that is being practiced. So it's a dialogue between what are the needs from the practical side of management and what would be the kind of, let's say, theoretical optimum for management, purely from the resource-based point of view. So it varies. It can be granular, it can be less granular and more kind of putting different groups of trees together. But I would say that if we think of this kind of environment that forestry is practiced on, then I would say that in the northern latitudes, in the semi-natural forests, the tradition has been to use rather small management unit, typically from 1 to 2 hectares, because purely there is much more variation in the forest landscape itself. So it kind of forces you to do a little bit smaller management unit. Whereas if we go to plantations, it's rather typical that management units are fairly large. They can be tens of hectares, and typically one characteristic for them is that, okay, these trees, they were planted on the same day, they have the same origin, I mean, they're same clone or same seed source, and so hence these are the same management unit. But then what we see after a couple of years in practice, that there is actually variation in how the trees have developed. There can be some soil condition that causing the difference in growth, and there I would see this kind of a more granular approach to defining the management units, leading to site-specific management. That would be, again, this one of these benefit-bringing aspects of single tree level inventory.
Right. And going to the growth itself. So if one would assume that this is the way you do the inventory today, what would be the frequency of doing that if you also want to capture the growth of the trees? I guess in a very different from plantation to Nordic forests. Is 1 year good cycle for that in the northern forests? Ismo.
Yes. So, I believe that in Nordic forest, 1 year is quite often, so it can be even less. But on the other side, on plantations, it should be maybe more. Jussi,
Yeah.
I think.
Yeah. Kind of background reference point for the audience who are not from Finland is that the story in Finland for forest inventories has been that for quite a long time, for decades, the inventory cycle, the kind of common inventory cycle has been 10 years. But just now, this kind of shift is happening in Finland. We have this, actually we have two national level forest inventories running. We are so interested in our forest that we have two, not one, but two. But one of these, this kind of inventory cycle targeting forest inventory for private forest owners, family-owned forest, that is shifting from 10 years to 6-year rotation. So even here we are seeing this kind of manifestation that if the technology allows, then actually it can make sense to do more frequent inventories. But yeah, I would say 5 years, 6 years is probably the kind of, you are getting diminishing returns on your investment if you do it more frequently than that. But then again, our rotation is like, let's say 60 years. It varies of course a lot, but let's say it's 60 years, and let's say that in tropics it's 6 years. So then you already from that you can kind of draw the conclusion that okay, in tropics it probably makes sense to do it more than once per year because the growth is so fast and the change is so fast.
Yeah, I think that makes sense. And but let's say if the investment makes sense and you would do it once per year in the northern forests, and you would do it twice to 4 times a year in a plantation, that would be a great benefit for damage and pest and disease control, correct?
That's the point. So it is kind of saying that in the boreal forest, once in 5 years is fine. That assumes that there are basically no disasters. There are no natural hazards happening, which has been more or less the case in Finland, more or less. Of course, there are some, but they are not a big problem. But this, with the climate change, this is one aspect. The risk level for this kind of natural hazards, that's going to increase. That's more or less given with the climate change. So in future, if you come back and ask me whether once in 5 years is enough, I don't know. In 5 years, maybe the answer might be different.
Yeah. And like I said, if you assume this, and if of course, if the business case is there and it makes a sense, then I guess that the investment doesn't vary that hugely. How often you do it, depending on the investment on the hardware, and of course there's a software elements behind it as well. And that would obviously give very accurate growth numbers, because today they are more or less mathematical models how the tree grows, but having those accurate measurements with some frequency, whatever that frequency is, I guess you can put the AI to correct the growth models more precisely, and also see the differences within the species based on the area or the management unit.
Yeah, that's right. That's again, so not only doing the management more site-specific manner, but having the ability to kind of train your prediction machinery to give out more precise predictions. That's the other kind of upside from applying this approach. And purely from the inventory point of view, you are absolutely spot on in that sense that there are some built-in factors into this kind of approach that kind of favor the having more frequent inventories, because you make your initial investment and then the per inventory costs are, I would say, radically lower in that sense that you don't need to invest so much for each individual round of the inventory, because it's largely automated process after you've made your initial investment into it.
Right. So here are the differences between, let's say, traditional sampling-based model and the inventory that we are talking about here right now. There's reference to the red dots on the right-hand side. I can't really see them, but I can imagine there's quite a few if it's tree level. So what kind of a inaccuracies the traditional model give typically? I know there's a variation of everything, but let's say if I do 1% of a million hectares, what is my error?
Your error for the whole of 1 million hectares isn't necessarily that large, but your error for any individual management unit can be substantial, and that's what the blue box there is kind of illustrating this kind of halving the management unit level errors. So that's really the kind of the key take-home message from this slide is that the traditional inventory by nature and by necessity targets a specific level of accuracy on a kind of overall accuracy, but then the variation at the management unit level can be fairly large. Whereas we start building the whole inventory from individual trees, it means that it's already fairly accurate at tree level. You saw that we have some, not everything is measured, something is modeled. Well, if you model something, you will always have modeling errors, that's for sure. If you measure something, you have measurement errors. So of course this method also has measurement errors, but they are, I would say, very, very small. But
that was clear as a mud.
What I'm saying is that basically, if I exaggerate things a lot here, on the left, our basic inventory unit is your whole forest area, and then you want to have accurate results for the whole area. On the right, our basic inventory unit is single tree, and we already have good results for the single tree, but when we then add all those trees, those tens of thousands, hundreds of thousands, millions of trees together, then we have really accurate results for the whole forest area. So we are talking about completely two different things. When we are talking about forest inventory, but the approach is completely different, and it leads to completely different accuracies as well.
And it enables the, let's say, the real site-specific management, because individual management units are accurately measured. I think that's one point as well. Yeah.
Absolutely, that's the benefit that we can get out of having those.
So all of this is possible today. I guess somewhat new still is not. How do you see the evolvement? I feel like a lot of things have happened now in the, let's say, past less than 5 years. The equipment is becoming cheaper. I think there's a lot of practices within this space. Are we ready for this?
Yes, we are ready. I think now we are in the position where we can say that we can really do tree-wise inventory. So we have been now practicing it for a couple of years really, and we are ready to proceed. There will be new things coming like LiDAR, and we are able to detect stem volume, for example, directly from LiDAR after a few years. But that is not yet here. So at the moment we are really confident on this camera-based method, and this is right moment to start.
Right. I guess when talking and LiDAR is certainly becoming more common, and it's commercialized in cars, even on the phones nowadays. I guess it's that equipment has come down in price significantly already. I think the camera-based is still less expensive than LiDAR. Is that correct?
Yes, if we think about the investment, it is much less. And then finally, if we think about the service cost, it is less if we are using camera-based system. And when we are talking about accuracy, so we can reach the same or even better level of accuracy. So I don't see any reason why to wait LiDAR.
Right. Okay. And as far as the technology, as mentioned, both the camera-based and the LiDAR-based measurements create point cloud. So is that exactly the same? Is it easy to switch or add LiDAR layer to it later?
Yes, so it's same kind of data for processing purposes. So it's easy to switch into another system.
Yeah. So going to these takeaway messages. So the digital twin based tree level inventory is certainly a backbone for smart forestry or precision forestry. You can't really, there's a lot of technologies around it, but if that data is not correct, then harder it is to do a site-specific management. I think that's a given. There's no really barriers anymore to implement it, and I know most of the companies have already, to a certain degree. They are doing in the smaller areas or having tests going on, or I'm sure some even does the full inventories on those. So that's gone forward. So the benefits for the forest owners and the timber buyers, Jussi, can you elaborate that a little bit?
Well, basically, we've been already talking about the benefits from the forest owner's point of view, which is this kind of, you have your tree stock and you want to grow the tree stock the best way possible, and that's, in order to do that, you need to really know what do you have right now, and B, how is it changing, and this definitely kind of is the key enabler for doing that. And that once you have this more accurate kind of description of your forest asset, then of course it automatically kind of decreases the uncertainty if you then do an asset transaction or valuation. So that's another aspect of value for the forest owner, besides being able to manage the forest better, is to value the forest better. But then of course it also translates for the timber buyers, and here we come to the subject that I was referring to about, and also Ismo was referring to. We are really interested in the tree stems themselves, and we can either measure them in the future, as Ismo said, or we can then model them. And the better we can model them, the better the timber buyer knows what is the actual yield in their end products from the value adding processing of the tree stems. So that is kind of win-win coin for both for forest owner and for timber buyers.
What would you say, and this might be a hard question and is, but what would you say going from, let's say you have a mix of different kind of forests, you go from, let's say, current standard ways of proceeding to a site specific management, what is the potential in the kind of volume increase in timber?
That is indeed a hard question. I would say this is kind of a, I seem to like this multiplier concept today very much, because I'm bringing it into every single possible answer that I'm giving to your questions. But again, the intensity of your management is here the multiplier in that sense, that if you're really doing intensive management, it means that then you have the means to really affect the tree growth with your management actions, and then you can in some cases increase it to 10%, 20%. I'm sure there are cases like that. And then again, another related aspect is this disease monitoring. So if you can detect those and react to those in a timely manner enough that you can actually prevent these effects, then we are talking about the possibilities of total loss of the stock versus having your stock. So it's kind of infinite improvement in that case.
Right. And I guess on the, let's say, especially in the plantation environment where growth cycles are fast, and you would get that feedback also from the sites to the R&D, I think that would be another aspect of getting the benefits.
Absolutely.
All right. We are running out of time. So the next webinar that we have is on March 11th, and we go into Jussi's favorite topic, which is the simulation and optimization with the tree level data. So I guess you've done a long career already in the simulation and optimization, and we're going to talk about how that changes with the tree level inventory data, so accurate source data. How much more accurate is the simulation and optimization possibilities after that? So that's on 11th of March. Please register when the registration opens, and we are likely to send some invites as well for that. Thank you for joining, and looking forward to see you all again on March 11th. Thanks very much.
Thank you very much.